We're going to go ahead and walk through how to perform electrical safety tests on this ESU Force FXC. It's important that we make sure we follow our safety protocols and our proper PPE before doing any service on any medical device, particularly on these ESU devices. Before we begin, we want to make sure we've configured the test properly for what the manufacturer requires in terms of the testing that is necessary and what the pass-fail limits are. You could program it on the ST analyzer itself, the Prong Safety Sim, or we can also program it via a Mobilize app that communicates to the Safety Sim. You can find this app on the Apple App Store by typing in Prong Mobilize to download the app. Once you've downloaded the app, you initially go to the Setup menu to connect your Safety Sim to the device by going into this middle section here where it says Device Connections. Locate the device you're connecting. In this case, we're going to be connecting the Safety Sim. You tap on this field here, it'll open up a window for you to locate any mobilized devices available to pair to. The ID of the device equals the serial number. You select it, and then you hit pair, and it will connect that safety analyzer to your Mobilize app so that you can control it and perform all of the testing necessary. At the top here, you can customize this header information. This information is important because it gets added onto the report when we've completed the test. Once we've connected our analyzer to the app, we want to go ahead and configure the test for this Force FXC. You can actually do that via the Mobilize app as well. You hit the Setup key, edit device types, go to Customize ST profiles at the bottom, and then here you'll see a library of electrical safety auto sequences you can create and store. We've kind of already created the ESU Force FXC. I'll show it to you so we can walk through what the testing requirements are. So here at the top you could set up the name of the test that we're going to run. We've gone ahead and already named it for this particular device. It needs us to do electrical safety testing for a variety of things, so we need to program some settings. Here is the device under test, the DUT on time. How long do we want to perform each electrical safety test before we advance to the next one? Here it's defaulted for 2 seconds, which is a good time to do each individual test that's required. Next is DUT on-off repeat. And this is whether you want to repeat the safety testing twice, with the device under test off and again with it on. For the Force FXC, we do not need to repeat it twice, just with the unit on. Next field is DUT power at the end. We enable this so that power stays on the electrical safety analyzer to the ESU at the end of electrical safety test, in case we want to do some more functional tests. Simulation auto sequence, you could program these. We're doing an ESU, so it's not necessary. And then the ground resistance limit. For this FXC model, the service manual does not call out for a ground bounding test, a ground resistance test. But for the purposes of this procedure and to be confident that our ground bonding is secure, we're going to go ahead and turn this test on and set the limit as the other ESU analyzers are set to, which is 300 milliohms. So we're going to go ahead and program to do that ground resistance, that ground bonding test. And then below here we have the individual tests that are required. So you have the menu on the left of tests that are available. You have the fault condition here in the second column and the third column that you want to go ahead and run. And then you're able to do this in normal polarity or reverse polarity or both. Then you have your program limit. And we need to configure this based on what this Force FXC requires. So this device requires us to do an earth leakage test or a chassis leakage test. We went ahead and programmed the chassis leakage test in what they call normal conditions, which is the ground closed, the neutral closed. In normal polarity is required to be done, and it's got a leakage limit of 100. So that's been programmed. We also need to do this same chassis leakage test, but with the ground open, or what's called a single fault condition, neutral closed. And we're going to do this again in normal polarity only, and the limit is 300 microamps. That's the second test, and then the third test is a output channel test, and we're going to go ahead and run a lead leakage, what they call sink current test, which in terms of the safety analyzer, that's running an ISO test, or it's also commonly referred to as a MAP test, a main unapplied parts test, where you're applying 120 volts AC to the analyzer to verify how much current it sinks. And so you'll see in the service manual, it calls out for using a multimeter and making sure you're using a 120 k ohm resistor to do this test. Well, that's referring to kind of a manual way to do the electrical safety test. But since we're using the safety sim, that resistance is built into the unit, and the unit itself will apply the mains voltage to the device, so you don't need to configure any external things like that 120 k ohm resistor. And of course, the limit here for this test is 20 microamps. So we need to make sure we've configured the test. We went ahead and done that, and we can be ready to perform this test. So we have the device, the app set up ready to do this test. It will communicate to the safety analyzer to perform it once we're ready. Now we need to get the actual ESU connected to the safety sim. To do that, we of course want to plug it in to the unit, the safety analyzer here on the left, plug in the power cord to it. You want to take the red test lead cable, make sure it's plugged into the upper jack of the safety sim, and connect it to the ground post in the back of the Force FXC. And now we also want to connect our outputs to the safety analyzer. And you want to do that for all 3 of the ports. And you want to do it by making sure you're connecting your test leads to the to the far left port and the far right port, the outer ports, on each one of these channels. So you connect these red leads from the output port over to any of the snaps on the safety sim. They don't need to go in any particular order. You simply take the banana plug side and slide it underneath any one of the snaps to connect it to the analyzer to do our leads test. So we want to do that for each one of these ports, and you can see I've connected these already to it. And the same with the REM line. You want to use your test leads to connect to each one of those posts within the unit itself, and also connect those to any snap on the safety sim itself. Next, we want to power on the unit so we can begin to do the test. So we're going to go ahead and power that on, and we're going to give it a second for it to turn on. And so the testing needs to be performed with the unit on. We'll wait for it to go ahead and do its initial power up sequence. We've already connected everything to it. And then we're going to go and back to the Mobilize app, and we're going to enter in the serial number of the device under test, or if you have a barcode, you could use the scan function to scan that barcode to automatically enter it into the unit. In this case, we don't have barcode on this device, so I've already gone ahead and entered in the serial number of the device. Now we go over to the menu here and select App Profiles so you can see all of your automated electrical safety tests that are programmed onto the Mobilize app. And we want to find the ESU for FXC sequence we want to run that I mentioned earlier that's been programmed onto the app itself. You do this, and then we have everything connected, and we're able to initiate the test and hit start. So it's going to go ahead and start to do the test. And the first test it's going to run is the ground resistance test. And it automatically told the analyzer to do that test. It's running it, and it's going to save that result and go on and perform only the test we programmed it to do for this FXC device. And you can see here we're running through a chassis leakage test with the open ground. In the center here you have your measured values. Below that is the current draw that the device is drawing during this testing. And once it's done, you'll see that on the app itself and on the safety analyzer itself as well, you'll see a green indicator letting you know all of the tests have passed. If any test has failed, you'll see that indication on the analyzer and on the app that a test has failed, that you'll need to diagnose and troubleshoot as to what could have failed on the unit. Then of course on the app you have a complete report of everything that was tested on this Force FXC, including the serial number of the equipment you used, the date that it was calibrated, and then below that are all of the tests that were required per the manufacturer's procedures, with your measured values here in the center versus the limits here on the far right. So we've completed the electrical safety test on this Force FXC.